This is a production of Cornell University.
Yeah, let's kick off episode 6 this year of the Cornell Turf Show. Our lawn and landscape show today is going to feature a conversation with Dr. Karl Guillard of UConn. We're going to talk about a bunch of research projects, fertilizer related, maybe soil testing related, so we'll get into that later. But as always, Frank, it's our third week of the spring here. You always got a nice little weather wrap up for us.
Yeah, good morning, everyone. For those joining, listening on the podcast or watching the recording, welcome to our Lawn and Grounds Management Edition. I'm actually traveling this week a bit, and I'm in a part of the country where I could take a picture of a person doing this. So it's in many parts of the country where things are getting going. A lot of things are getting applied. And I think, as we said in the first week, a lot of times productivity matters a lot more than optimum timing, right? You try to find an optimum time to do things and you wind up working around it. So before we get to Karl's tip of the day, somebody shared this with me recently, a hand unit playing around in the backyard somewhere in the UK. People are nuts about grass and their lawns, right? And one of the things that I've always sort of has been the guiding principle is that I want to help this guy. I want this guy to be able to absolutely do this. And I actually think he can do it with, other than mowing, not many inputs. The biggest problem he's got is he's got to mow it all the time because it's pretty low. But other than that, in a place like England where it rains a fair amount, where the soils probably have enough organic matter in it, I don't know what kinds of pest problems he has, but I want to help a guy like this. So Karl, why don't you give us your stat for the day before we get into the conversation about keeping that stuff sustainable.
Yeah, and we talk about value there, Frank. The value to that individual homeowner is probably aesthetic, and there's probably some mental well-being value going in there for them maintaining their lawn. But I've been interested in trying to quantify urban green space value. And of course, a lot of that is turf, but there's trees and shrubs and other vegetation included in that. And the best numbers we can come up with in terms of dollars and cents is really looking at urban green space and the value that provides to water retention and reducing stormwater runoff. So there's a couple of studies here. This one is from Finland. Basically what they did is they looked at urban green spaces. They looked at the amount of water that penetrates the ground because of that permeable green space surface. And they compared that and the cost to set up a green space and to manage it to the cost of what would have been an impermeable surface, maybe a housing development or parking lots, and the cost of building water infrastructure, the pipes under the ground. What they found is urban green spaces can generate between $1,300 and $3,600 per acre per year of urban green space. So those are some pretty cool numbers to have. There's other studies that have it as high as $8,000 or $10,000 per acre per year. These areas can allow about 70 to 80% of the precipitation that hits that area to infiltrate back into the groundwater. That's really good. It diverts all that water from the stormwater system. So it's really cool to have some values. These are the best ones we have for water. It would be cool to start quantifying this in terms of noise pollution, maybe air temperature reduction, where it doesn't look like we're there yet for a lot of that stuff with turf grass, but just a cool little number to keep in your head when you see maybe some, I know golf courses frequently, when they close in urban areas, they get rezoned to impermeable surface. It might be good to have some of these numbers when we're looking at situations like that.
Yeah, and I would venture to say they're modest when you consider what you'd have to build, right, to compensate for having all that pervious ground. It's unbelievable, Karl. Yeah. This is a great stat. Thanks for doing that. All right, let's look at the weather before we get to our guest. And just to remind you, this time last week, we were talking about how warm it was the week before. And now you can see red, even the deep red, basically means normal, which means the entire region, no surprise, was well below normal. And our esteemed climatologist, Art DiGaetano, Professor DiGaetano here at Cornell, called it pushing the pause button on the growing season. So you can see, high elevations as much as 14 below normal, but certainly along the coast, a little warmer, inland, a little cooler. Precip, again, generally adequate. Most people got between a quarter and a half an inch. A couple in northern reaches got even more. The Connecticut River Valley and even Long Island looked like they got about an inch or two. So pretty moist, not lacking for moisture. And looking forward, the 6-day 10 outlook is calling for mostly normal, but near normal, but above normal along the coast. So if we look at our forecast website from a growing degree day perspective, how the entire growing season will progress regarding heat units and how it's all advancing biologically is going to be governed by growing degree days. At least that's the way not governed, but somewhat easily tracked using growing degree days. And you can see we're still not accumulating very many throughout the region. So, we're looking at 40 to 50 degree temperatures, lows in the 40s at night, highs in the upper 50s. So 40 to 60 degrees looking forward. Rainfall looks like we're going to be wet again. The prediction for this the next 6 to 10 days. And if you just look at the next 3 days, our forecast for the next 3 days, you can see actually a nice swath going through the Hudson Valley and with the Pioneer Valley, almost a little over an inch, maybe even as much as 2 inches in that swath in areas where I'm not sure they actually need the rainfall. Now to the south, when you get down South Jersey, Philly, they're on the dry side. So some of that moisture could be very welcome in those regions. All right, let's keep going here. Now, the soil temperature just the other day, again, if you recall last week, we were as much as 52, and now we're lucky to be reaching into the 40s, upper 40s. And now that doesn't look like it's going to be changing dramatically. So again, that pause button is clearly what's going on. Now, the interesting thing, and I talked about this yesterday in the golf session, Matt Elmore tweeted out that the Japanese stiltgrass is emerging. Now, you may not even know Japanese stiltgrass unless you're working in a landscape with a lot of shaded areas, particularly around the New York metropolitan areas where we're seeing it expand dramatically. It's a very highly invasive plant. It's a C4 plant, so it's actually a warm season grass that has really high shade tolerance. And one of the things that we're seeing as it starts to come out into shaded lawns is because it comes out so early, it completely evades a lot of our pre-emergent crabgrass materials. Now, as we get on during the season, I'm going to talk about maybe Kailinga and maybe goosegrass that are also successfully eluding or missing, getting away from our pre-emergent crabgrass stuff. So I think it's something moving forward we're going to talk more about. The spring continues to progress. For those of you that pay attention to the National Phenology Network, while we have hit the pause button, we still are fairly ahead of normal when you look at leaf index from just the other day, how it's progressing along the coast and moving up into the interior of the Northeast. Now, I talked a little bit about it yesterday. I want to expand a little bit about this today before we get to our nutrient conversation. This concept of false springs, right? This is this has a lot of implications. Of course, I don't have to explain this very much to fruit growers east of the Mississippi because they experienced this issue a number of years ago. When you look here at this chart that was a position paper written about why we needed more research on this kind of information. You're looking at what they're calling false springs, the 30-year average, and a typical spring, right? So a typical spring, you see this dark blue line here. Here's the gray line. It's a normal spring where a 30-year average, where temperatures stay well below normal and plants remain dormant. They start emerging well after the risk of serious frost or cold temperatures is going to occur. This idea of false springs is this extended warming period now that we're starting to see where plants break dormancy and then make them more vulnerable to frost. Now, of course, the golf industry is dealing with a lot of this now from potentially with the winter damage that it's experiencing. But I actually talked about it yesterday. I'll refer you to it again today. There's some really cool fall spring research going on at the University of Minnesota looking at tall fescue, turf type tall fescues that are a little bit cold sensitive when you put them out in the plains, cold states like Minnesota. So Florence Sessoms is leading a project in Eric Watkins' program out at the University of Minnesota where they're building these tents over these areas, and also doing similar work in the greenhouse and growth chambers. And on the left, you see a plant, the plants over here coming out of dormancy very successfully, no damage. Here is 1 day of warm up and then followed by cold temperatures. And here's 5 days of warm up, followed by 5 days of fall spring, followed by cold temperatures. And you can see tall fescues are going to have some particular problems with that. And I think golf's got, annual bluegrass, that's one of those issues. And I think a lot of our recommendations for turf type tall fescue, I think still work for us because our winters are still pretty warm. But in Minnesota, in places like that, we're definitely seeing even lawn grasses impacted by that warm up. And then just a reminder about seeding at this time of year. A colleague at Purdue University many years ago did a study looking at timing of seeding. And of course, no surprise, Kentucky bluegrass, tall fescue, and perennial ryegrass, right, across the board successfully look good when they're seeded in September, right? The following July, right? The following year, right? Because that's ideal timing. You get a little later and you see perennial rye does good. You get into November in Indiana, you still got good conditions. You can get good tall fescue, but the focus here is spring growth. So there actually appears to be some benefit, particularly if you want to increase your Kentucky bluegrass populations in the spring, is to start seeding those plants now. Looks like tall fescue and ryegrass do pretty good with early seedings as well. All right, Karl, now we're going to start the conversation about this wonderful publication that I know you were involved in. I think Marty was involved in it years ago, looking at fertilization of turf. And I look at this a lot at lawns, particularly from a water quality lens, right? How do we make sure we're maintaining regional water quality? And it's very simple. I don't want to spend a lot of time on it. Right rate, all the basic things we know. You did a wonderful job. I commend people, Karl. Let's put the link in. I've talked about this in the past on the show. And for those of you listening, you can go check the recording, or we can find a way to get you the links for sure on the website. But for sure, non-sensitive areas, trying to lay out a program, and more sensitive areas in very simple terms. This is maybe not ideal. Now, the next evolution, I think, beyond sort of nitrogen management and the things that came up in that publication are, the whole idea in the spring that we soil test, and we got to get that fertilizer down to meet those minimum expectations. And now you're refining this for the University of, for New England soils, right? So you've got this project underway, and I'm going to give you a chance to talk about it. But what I want to talk about is the cooler paper. I saw your grad student present this at the crop science meetings. I think it was this. It might have been an evolution of this. Correct me if I'm wrong. But in this case, I want to focus on how we can use MLSN for everything, but really you can't use it necessarily for nitrogen. So one of the things that underlies the challenge with testing for nitrogen is that you don't know how it's going to release. It's transient. Will a snapshot tell you anything? And some of the basis for this thinking goes back to the 70s that soils build organic matter. This is actually Lawn Soils on Long Island, the very famous Water Resource Institute paper that's been cited a million times by people, that shows how the nitrogen concentration in organic matter continues to increase. Now, Karl, here's where I'm going with this, brother. And I know you're lined up with this because you've done this work. But when you look at Kevin Frank's, the Michigan State monolith lysimeter work, right? Early on, they applied fertilizers, and you can see here, did not get any leaching in the early days. Now, this is year 6. So in years 1 through 6, all of these leachates from these 2 fertilizer strategies, this is 2 pounds and this is 5 pounds, right? There's 2 fertilizer strategies here. It took many years for it to build up before the high rate began to become very leaky. And when you look at it over a really long period of time, after that pulse 6 years in, they lowered the nitrogen, the larger nitrogen rate down to 3.5, 4 pounds. And you're starting to see those numbers come way down. I haven't looked at this data since, but it can't just be that the fertilizer rate you're applying is leading to this. Now, we then use some of this stuff, Karl, to write a few years ago when some legislation was coming through on defensible nitrogen rates, right? How much could you put on reasonably? What does research say you could put on reasonably before it like leaked out in a study like this, like long-term and short-term? So depending on what you use the turf for, it could be as little as 1 to 2, could be as much as 4 to 6. But ultimately, we came down in the, it looks like 2 to 2.7. You want about 0.5 to 0.7, no more than that in a single app, depending on the soil. But it pales in comparison to what you're trying to do with this particular line of inquiry, trying to predict with some tools. Soil health people use different tools. This idea of developing a SLAN, a sufficiency level for nitrogen. And I'll cut right to the chase, Karl, and then I'll give you the chance to chime in here now, because there's, I'm sure, a lot to unpack here, brother. But ultimately, what I gathered from your work was basically asking, is there a way that we can test and then have some probability, like, okay, if it's this and I add fertilizer, is it going to be any more than X? So to me, this is honing in on it. It might have problems, right? It's only testing maybe on one soil, even though you've got 2 species over a 9-year period. So I mean, it's a good body of data that did this work. But I'll leave the graph up here for a second and invite you. Welcome to the show, Karl. I hope I'm not taking too much time now, but how are we doing on time? How are we doing on time, Karl? All right. So I'm going to shut up now, Karl. What do you want to start with? Where do I ask the question? How did this work turn out? What do you think?
All right. So the basis of what was really driving this work is that what is the correct rate of nitrogen? We tend to use a arbitrary rate because it's like, well, the best science may say this, but we'll cut it down a little bit. We'll look at some leaching data. We'll do this. But the problem with that is that every site is different, but we're using a generalized rate across a huge geographical area at a specific, and I call it an arbitrary rate. Now, is that rate right for you? It may be. It might be on your instance on there, but we are really guessing. We are really guessing, and some people guess very good. A lot of long-term turf managers who are still successful in the business, they pretty much have an intuitive sense of looking at their turf and saying, it looks a little hungry, you might need a little bit on there. But we really still don't know. And as the graph you showed from the Long Island study on there, we do have mineralization potentials. So our thinking here, and this was more of a proof of concept, can we use a particular relatively easy commercially available test to give us an indication of what our mineralization potential may be? And then backward from that, once we do know, can we classify our turf areas as to their particular response, what they may have to a nitrogen response? Now, I will guarantee that every turf manager that is in here listening has some areas where they have put nitrogen down and may have seen a response, or maybe put nitrogen down and may not have seen as big a response as maybe they were anticipating. We all have that. We all have those turf areas in there, but we tend to stay with a single common rate, particularly if you're in the business of doing that. Time is money, and you calibrate your spreaders for doing basically the same. Where you get out there, you put it on there. It's a business model type of a thing. So we're trying to look at, is there any way to help with that? Now, also, every turf manager actually manages by probability. What's the first thing most turf managers do every day? What's the very first thing? They open up their app on their phone and look at the weather. What's the probability that it's going to rain? That drives so much. Or what's the probability of a certain temperature? That drives so much of turf management. So what we were trying to do is, since most turf managers already do this either as practice or instinctively, looking at probability, let's put this into a nutrient management aspect on there. But they really haven't had any tools other than visual cues at this point to guide that. So we looked at these Solvida tests that are commercially available. I have absolutely no financial interest in this.
I know the paper says it. It's funny when you publish a paper nowadays, Karl, they make you disclose all this stuff, right? If you read down the disclaimers. So that's good. Let's say it that way. People know it. We're not pushing any particular test. It just happened to be a tool. And again, since I may not ever get you like this again, you've been at this for a while, Karl. I've been trying to get, you tried those little drip sap tests. Then you did the DGCI, the spectral imaging testing. I mean, I've known you, I've paid attention to you for a long time, and you've been at this. I guess before you go into this a little bit more, is this what you're thinking you're leaning towards? Is this the natural evolution to the work? Do you think this is the place we're going to find a way to take the arbitrariness out of it?
Well, it will certainly help. I think right now, I'm confident that at the least with these tests, you should be able to use these to at least categorize your soils. So, and we present in the papers, and anytime we present this information, we give a generalized type of fertilizer adjustment. So really, if you would say use these tests in your turf area, and some of this for some turf managers may already intuitively kind of suspect. It's like, I put a lot of nitrogen down here on there, but I really don't see that great a response. And I've even cut down and it still looks about the same. So that means you've got a lot of natural mineralization or available nitrogen going on. You don't have to put as much nitrogen going down. So we're pretty confident that these tests will, at the minimum, allow you to designate your areas that you are managing as to their probability of response. If the values come out very low on the test, you may need to put on what your current rate or what your maximum rate or your optimum rate, let's say. And if it's at a little higher level, well, maybe you can cut down maybe to 3/4 of what you put down. And if it's a little higher on the values, maybe cut down to half or a third. And then if it's high values, maybe cut down to 1/4 or maybe nothing, and just see what happens until.
All right. So let me ask you a couple. Let me ask you a couple of questions now. First, give us a little primer in simple terms on an elevator speech. What is a Solvida test actually measuring? I associate it with compost testing, right? I associate it historically as a compost test. You're telling me I can use it potentially as a diagnostic tool for soil N. Just a little snippet in what a Solvida test actually is measuring.
Excellent point. And I should have mentioned that it was indeed originally developed as a compost test to say whether or not you've hit that heat rise and you've got a cured compost. However, when that information came out, a lot of the soil scientists immediately saw the value of maybe looking at organic matter, decomposition, soil respiration. And so they do have a test developed for soils. And this is the Woods End Laboratory up in Maine. And they have developed one specifically for soils. Now, it is abbreviated as the SLAN. And unfortunately, I think that's a unfortunate abbreviation because we already have a SLAN for sufficiently level of available nutrients for something else.
What is their SLAN?
Yes, their SLAN stands for the soil labile amino nitrogen test. So it's actually measuring a very, very active or reactive or highly mineralizable form, a labile amino nitrogen. And labile just means it breaks down very, very quickly. It's an active form. And so most of that amino nitrogen is actually tied up in the bacterial cell walls.
Yeah.
And so, and particularly if turf, you look at the literature under grassland situations, the microbial biome population is dominated by bacteria.
Okay, let me ask okay, so this is the interesting point. Now, I'm going to get in the weeds, but it has a big practical implication. And it's one thing to do this Solvida test and tell me the probability that adding a fertilizer might work. But what I've realized from, particularly now that you've introduced the microbial aspect to it, how do you relate this to how a soil or a fertilizer will respond when the soils are cooler and not able to process that mineralizable N as effectively versus the heat of the summer when they're warm, and when it rains, you see how your soils function, right? Because temperature isn't limiting them. It rains in the spring, you don't get a surge. It rains in the summer, you get a surge. How can I build, as I'm thinking through a spring nitrogen application, is this a good tool for that? Or I have to wait maybe till that microbial system gets going to be able to use this tool?
No, oh God, Frank, these are all excellent questions. These are really, really good because this data was actually based on a single early spring test. So we figured that the way we were developing this test is that let's not have any other additional task that most turf managers do. We assume most will either do in the spring or the fall. Now, what we don't have on this particular study, but we do have on the one we're finishing up now, is that how does this change across the season, right? Yeah. So that's the question you're really getting at. When's the best time to do this? Well, it turns out if you are not putting on a large amount of organic matter additions each year, now maybe some of the organic folks will be doing this, but generally in the most part, this does not change that much over the season. So the data we have now, and it's not presented in what we're showing now, but I'll tell you, we're working on that data now, is that, and there's another Solvida test too, called the carbon dioxide burst test. So they're very similar. And the CO2 burst test is more of microbial activity. And but they're correlated very, very well. So either one. And we find that with the Solvida SLAN test, taking that anywhere up through most of the growing season, we do find it dropping down as you get into late October, November. So it does drop down a little bit. But that may be due to plant uptake of what is available in the amino nitrogen.
Okay, so again, this may be my last 2 minutes getting to ask these good questions. So I'm going to take advantage one more time. Before our former colleague, who has moved into retirement many years ago, Marty Petrovic, Marty and I used to talk about this endlessly, right? Because of the Long Island stuff. And it's like, he always felt the same way you did. Marty he was the sort of guy who used to get called to court all the time for as an expert witness. And he goes, Frank, I'm not putting my hand up on a stand and testifying to any nitrogen rate. That's what he used to tell me. But he did used to say this. He goes, my sense is once these lawns mature to a certain age, 25, 35 years, that essentially every time they get a certain amount of water, they're going to release nitrogen, right? They're going to, and in fact, you could look at fertilization between certain soil temperatures by just how you water. If it's dry and you throw some water, you'll get that system functioning. Do you really think that that's probably something we could think more about? That one way to think of it in simple terms is if you want to cut back applying fertilizer when your soil's warm, which might be when this pool contributes the most, you could do it by maybe, if you had an irrigation system, just slinging some water.
Sure. Well, the other thing too, with a lot of, particularly in high cut lawns, a lot of this clippings are being returned. And so that needs, so all of that needs to, up until this point, we really don't necessarily account for that. We know, if we want to be intellectually honest with ourselves, we know that this is all contributing. We get atmospheric deposition, maybe a little bit the irrigation water, all that, but it's never accounted for because we haven't had the tools, I don't think, or easily readily available. Now I think we do. Now we think we do, and I think this has something to that will help with that. It's like anything else. It's going to be a change to the current system. And what I have found over the 20 plus years that when I got into turf working on nitrogen, I thought, oh, good, this will be easy. I come over from forage grasses into turf nitrogen. I'll knock this out of the park in about a year or two. And so 25 years later, I'm still, trying to figure out what's going on. So it's going to be changing human behavior in practices. It's got to have a political will from the standpoint of not being to any political organization. No, I mean a political will of making a decision based on a business model decision. And I've advocated for these tests to be, if you're in lawn care company or something, introduce these tests as part of your monitoring program. Charge.
Well, all I can tell you is, and Karl will appreciate this, and maybe we'll take a question, Karl. Karl, we'll take a question or two if there's any. But I will say that partly what's always fascinated me is I've always felt like you've tried to get us more quantitative ability to do these things that I thought was arbitrary as well. And I look at it, Karl C, as an eagle in our BMPs, right? If you're a lawn care provider and you want to do best management practices for water quality protection, and you really want to dial in your nutrient program, instead of just offering an organic service, which seems to dupe people into thinking it's sustainable, why don't you say, let me dial in your rate by seeing what your soil's going to do? I think there's a lot of hope for that, Karl. What about a question? We got any questions from the group?
Yeah, so one of the questions is actually from Ben Polymer asking about how much N is returned when you're returning clippings per year. And I've seen about a pound, depending. It depends on how much growth it is too. But I think the bigger question is, and one of the topics, the themes I'm noticing from your guys' conversation is, we've always known these general principles. If your soil has high organic matter, it's going to have more mineralizable N. If it's a sandy soil, it's going to leach quicker. If you're applying more fertilizer, if you're returning clippings, all these things we know in our head, kind of how they change our fertilizer. But what I'm hearing you guys talk about is we're moving closer to like a model of growth that we can input. Okay, I've got X turf species, Y soil, and my Solvida CO2 burst test says this. Here's the probability of a fertilizer changing my growth rate. Does that sound right? And Karl with a K, do you think that's on the horizon for us?
Well, sure. Look how much we're doing now with our mobile devices. It's used so many apps doing everything, and they're even, I didn't even mention it, but Frank knows that I've done work with turf reflectance and meter, and you can get that on your phone now or your iPad. You can get programs to do that. And I don't see why not. There cannot be something where you go out with your phone, snap a few pictures, and then with certain apps, input your soil information, some of the weather data on there, and at least come out with a mechanistic model to give you a probability of whether or not you need to apply or should apply. Maybe that's going to be putting in and including some of the Solvida tests or whatever other information that you have. Yes, we're doing that now for everything else. Why is turf like this magical, untouchable, magical beast that, a pound of N per 1,000 square feet per year at every application?
It's so great.
3 or 4 times a year. You're
looking back at the bridge you built for 25 years and you just throwing gasoline and throwing a match on it.
Yeah, I'm burning my bridge. Now, the other thing, if you pop up Kevin Frank's data on there, look when most of the leaching occurs. In northern climates, it's in the fall and early winter. What do we do right before then? Well, we've got our paradigm of fall fertilization. Why in God's name are we putting down fertilizer, nitrogen at a time when you know that most of it, and look at, and I'll, if you don't believe my data, look at the data that Cornell has done what Doug Soldat has done and doing that. And every time anybody now is dialing in, looking at fall fertilization, it's like, maybe we better rethink this because we're losing.
Yeah, I think there's been a shift in that. I really do. And listen, Karl, only because it might be the last time we get to chat like this. We went over the fastest 30 minutes into 36 minutes. Karl Guillard, so great to see you. If I don't get to chat with you again, I hope you have a wonderful retirement. And I'll just tell you, you have made an enormous contribution to a discipline that you thought you were going to fix in a year. I was glad you hung around for 25 years because it really has made, I think, for those of us paying attention to want to be better at it, I think you've really contributed a fair amount. Thanks, Karl. Thanks for joining.
Appreciate it. Thanks.
Love it.
Bye.
All right,
Thanks,
Karl,
everybody.
get us out of here.
Yeah, we'll still call it the fastest 30 minutes. It probably felt like that. We're getting Karl and Frank all worked up about nitrogen and fertilizer. So thanks everybody for joining us today. We'll be back again next week on Thursday for a golf show.
Take care.
Bye.
This has been a production of Cornell University, on the web at cornell.edu.